everyone. My name is Magda Stożek, and I'm very happy to be able to talk to you today about one of my favorite subjects, property-based testing. But to be honest, when I first heard about this, I wasn't too impressed. It was during my first months writing in Scala, where everything was new and confusing, when I noticed that each Scala project, each Scala service and repository that I see and that I join has this thing called property tests. So at first I thought, that's just another Scala thing. So I will get to do the same things that I already know how, but I will have to relearn it the Scala way. But when I finally sit down and understood what those properties are really about, then I thought, wow, now that's something impressive. That really changes the game. And the reason why I thought that is that with property-based testing, your role is to think of some properties that have to be always true. And the role of the testing library is to find the bugs and edge cases for you where those properties are not obeyed. So for this reason, I thought, wow, okay, someone or something is doing my work for me, my job for me. So I thought it's pretty good. But my second thought was, wait a minute, why am I learning about it only just now? Why hasn't no one told me about it before? After all, you can easily apply it outside of Scala, outside of the functional languages world. So today I would like to do just that. I would like to tell you that property-based testing exists, that it's pretty unique, and that if you haven't already, then you should really consider trying it out. So let's start with an example. Let's say that we are trying to test a method called calculate discount, which calculates discount in our system for a customer given the local date. And the customer class is, as you see here, the customer has a name, the date when they joined, and their date of birth. And the algorithm inside our production code is that if the customer is with us for less than a year, they don't get a discount. If they are with us for between 1 and 2 years, they get 10% discount. And if they are for more than 2 years, then they get 20% discount. And just to make things a little bit more complicated, if it's the customer's birthday today, let's give them a special 30% discount just that day. And we're encoding that in big decimals. So to begin with, let's start defining how we would test such a method in traditional tests. So as opposed to property-based tests, we can call traditional tests example-based tests. So what I would start with would be the happy path. So what the code actually does. It calculates discounts. So let's start, for example, with the 10% discount. So I would probably prepare the test where I would have an instance of customer who has joined 1 year ago and invoke our method and verify with an assertion that the discount for them is 0.1. So 10%. And similarly, I would prepare a similar test case for 20% discount. So an instance of customer who has joined 2 years ago and the discount is 20% for them. And a similar test case for birthday discount, an instance of customer who has joined maybe just now, but it's their birthday today, so they get a 30% discount. So those 3 test cases cover our business logic quite good, but we know that's not enough. We need to have the edge cases. So this was actually the happy path, and we need to have the edge cases. So what edge cases can we think of? We can say that, for example, if a customer has joined just now and they don't have any birthday, then they should get 0% discount, just to make sure that's correct. And also, let's make sure maybe that the discount doesn't grow indefinitely. So like the customer is with us for 10 years, they don't get 100% discount. So let's have a special test case for 20% discount, even though the customer is with us for 3 years. So in traditional testing, if I had such 5 test cases, I would say, okay, good job. I've got this covered. I've got this tested. Commit, push, and move on with life. Let's implement a new feature. Now, how is it different in property-based testing? What is this property? So the property is a rule that you define about your code, that you say that no matter what input data you give to your method, then the output always has to follow that rule for all input. So no matter what crazy input your method gets, the output has to follow that rules. And it's your role to think of those rules for your methods that you are testing And the role of the library is to try to break that rule, so to prove that you have an error or a bug somewhere there. So what properties could we think of in our example that should be always true, no matter what the customer and no matter what the local date? We could, for example, say that the discount should never be lower than 0, so that no matter customers, local dates, the dates of today, it's never lower than 0. And similarly, the discount is never greater than 30%. So those are very good properties. But you say, wait a minute, it doesn't really cover the whole complexity of our algorithm. You still can have incorrect data which would follow that rule. But that's fine. That's okay in the world of properties. Because, first of all, you can have several properties which cover different kinds of different parts of your algorithm. And then it's okay if it doesn't cover it all. It's okay to have a property which covers some part, some aspect, some approximation, because it's not as concrete as example-based tests. You may think of it as some safe, sane boundaries, so that no matter what crazy data you have, the output is within those safe boundaries, and that's what your properties are. We could also test your methods, like, for example, having 2 customers and making sure that there's a property which says that the discount is proportional to how long a customer is with us. And you can say in the test that whenever you have 2 customers and one of them is with us for a longer time, the other one is with us for a shorter time, then the discount for the older one is always greater or equal than to the other one. And that's also a property that has to be always followed. And similarly, we can test the birthday discount. So if you have 2 customers which follow that rule that one of them has a birthday, the other maybe has, maybe doesn't, then the birthday discount or the birthday customer gets the bigger discount. So this is a set of properties which could test our code pretty well. And we'll see that in the code in a minute. But before we talk about the code, let's talk a bit about libraries. So property-based testing is around for quite some time now. It has started with Haskell and Erlang, and since then, there has been a lot of implementations in many programming languages. However, here, because the library does the heavy lifting for you, it's important to find the right library. The better the library, the more mature it is, it will do better job for you. It will do better job finding edge cases for you. And for example, the Scala implementation is pretty good here. And what about Java? In Java, I think right now we have 2 mature and actively developed libraries for property-based tests, JUnit QuickCheck and JQuick. And during this presentation, the examples will be in JQuick. I recommend that. But all that I'm talking about here, you can implement easily in all other property-based testing library in all other languages. So let's see the code. Let's write the property that the discount is not larger than 30%. And now if you look at the body of the test, then it's pretty standard. You just have the instance, you have our method called, and then with an assertion, you verify that the discount is not greater than 30%. Here, this property annotation just tells JQuick to discover this test as a property-based test, but all the magic happens here in those 4 all annotations. Because what you say here is you say, dear JQuick, this is my property. Please verify it for me. And what JQuick does is it generates 1,000 random pairs of customers and dates, runs your test 1,000 times, and verifies that this property is still followed. Now, I said random, but this is actually much more than random. It's something that I like to call nasty randomness or vicious randomness. Because the better the library, the more tricky data it will try to generate for you. For example, if you are working with strings, get prepared for empty strings, very long strings, weird encodings that you didn't expect, and so on. If you are working with lists, expect empty lists, very long lists, lists that consist of all the same element, repeated over and over, and so on. So the library tries to break your code or break the property for you. And what happens if it does find an example where this is not followed? jQuery prints a lot of useful data here, but let's start from the end. So this is the actual example where jQuery found some problem with my implementation. This is where the test has broken. But actually, jQuery doesn't stop there. It tries to simplify this example to something that is simpler, shorter, but still makes your test fail. And this is called shrinking in the world of property-based testing. And also, a good library can make it better for you. A more standard library maybe will not have it or will have it very basic. So can you see right now what the problem was in my implementation? It's the 29th of February, so leap years. I didn't take that into account in my implementation, and it turns out that my code was actually throwing a null pointer exception there. So this is where property-based testing really shines. Because when we write the code, we often do it having a couple of concrete examples in mind. We write the code with those examples in mind, and we write the test cases with those examples in mind. So we're kind of biased. And the library is not biased for us. It will generate data or find out data that you didn't really think of, or didn't, it didn't pop into your head. So now, where does the data come from? In the world of property-based testing, it's called generators, what's hidden behind those for all annotations. And for basic data, you will get this out of the box, generators for strings, for numbers, for lists, and so on. But you want to have generators specific for your types. So if you have your main classes or entities or domain objects in your system, and they are used heavily in the test, then you want to have special generators which provide the exact data that is correct in your system. Because if the library generates incorrect data as an input and the test fails, it doesn't really tell you much. You want it to fail for correct data, because that's where you have an error. An example of what you can do if you don't have a built-in generator is you can combine them. So for example, here we have a property that the concatenation of string and number shouldn't be longer than 2. And here we are providing our own generators. In jQuery, they are called libraries, so you have a provide annotation and the method returning an arbitrary. And then what you start with is you start what you have built in the library, so this arbitraries class, which has in jQuery a lot of static methods that you can call. So here, this is all jQuery stuff. You just provide strings, but then you limit it with the specified char range, and then maybe you want to filter out something and have the minimum and maximum length. And the same thing we can do with integers. So here we are providing a generator or an arbitrary of integers, and you're saying that they need to be between 10 and 99. And if you had generators like that, then you can map generators on top of generators, combine them, bring them together, do all stuff that you need to do to make the generators generate just the right data with the right frequencies, which simulate what the real world correctness means to you. Now, if it's all so great, then why aren't we all using it all together? Why aren't we dropping out all example-based tests, and should we? Of course, there needs to be some fine print. And now let's talk about the fine print now. There are four main challenges, in my opinion, for property-based testing. The first one is it makes you ask difficult questions earlier. So when I write code and I try to follow test-driven development, then I write the simplest test, then the simplest production code, a more complicated test, more complicated code. Then I start to think about edge cases, adjust my code, and so on. And in property-based testing, before you write your first line of test, you have to think about what is correct data for you. What is the range? What is the accepted data so that you can have the right generator? And it may well be that before you write the test, you actually have to go back to your product owner and ask questions like, what is the longest surname a person can have in our system? What is the oldest age that a person can have, our customer? What is the maximum number of money that a person can spend on newspapers a day? And these are real questions from my past, from my projects, that actually have to be answered. And it's sometimes not easy, because who knows? So that changes the dynamics a bit. So that's something you have to get used to. Now, the second challenge is non-determinism. We don't like that, do we? It's kind of random data. So what can happen is that you test your code, it runs fine for you on your machine once, twice, 3 times. It's all good. And then you push it, and in Jenkins, sometime later, maybe today, maybe in a week, maybe in a month, it fails. So what do? For sure, what you don't do is you don't go to Jenkins and say, oh, this is flaky data, let's rerun it. No, you actually have to go there, look at what test data was generated, which made your code fail. Because maybe that's the library finding some edge case for you, or some hole, some misconception in the way you think about your user story or your algorithm. So that's something also to get used to it. But think of it this way, it's the library finding this tricky data for you, and not a customer in production a year from now. So that's a bit shorter feedback loop. The third challenge is documenting. I don't know if you have that sometimes as well, but for me, when I have some piece of code that I don't know yet, I sometimes open the test case and read the test file and read the first test case. And it's usually the simplest test case with just the data that is very basic. And it tells me more than reading the code itself, because it's the example. Our brain sometimes likes to think in examples. And with property-based testing, I don't think it works that well, because there you have some approximations, you are testing some bits and pieces of your code, or you have those safe boundaries. I'm not interested in that if I'm trying to get to know some piece of code. So for that reason, I don't think property-based testing are so good. So it's very good to have both example-based tests and property-based tests in your code base. And the last and the greatest challenge of them all is coming up with properties. Because how do you think of some rule, which has to be always followed, but then you cannot repeat really the algorithm, the production code, because that would give no value. So you have to think differently somehow about that. And it's kind of a creative process. So you might want to do it with a colleague, for example, talking about what the code does and what properties we could find. Sometimes it's good to come up with the properties maybe next day in the morning when you are fresh and your mind is fresh and you get creative. Sometimes you need to go for a walk, do something else, and then you come back, okay, I've got this great property which could test my code. But also we like patterns, and there are smart people who prepared lists of patterns for property-based testing. So this series or a blog post is just about that. That's a list of patterns that you can bookmark and have a look wherever you need to come up with a property for your code. So then you go one by one and you see, can I apply, for example, an invariant here? So something that doesn't change before running your method and after your method. Or can I test my code symmetrically? So for example, do I have writing to the database and then reading back from the database? And then I can compare the result to what was in the beginning, and that could be my property. Or do I have an oracle in the sense that something that knows, not as a company name, but something that knows the answer well. So for example, sometimes you have a piece of code which does the same thing as what you are trying to test, but maybe in a different language, in a different package, or it doesn't do it as fast as it should, but it knows the right answer. So in that case, you can run your code and run that Oracle implementation, that knowing implementation, and then compare the answers together. For example, in my experience, I used to have some financial calculations to do, and there was some standard, and the standard was defined as an Excel sheet with some macros, and then when you put some data in there, then somewhere in some other tab, there was the result. And I was supposed to prepare the same calculations, but present them in a different way, make it integrate in our system. And then what my test did is actually it used that Excel sheet to check the calculations and they were correct. And that was a very long story until I finally got the right approximations and so on, and my results were really similar. So that's a list of patterns that you can consult whenever you need to come up with a property for your code. So now if I'm saying that property-based testing is great, but it's not trivial because it makes you think about your code in a different way, and you cannot really get rid of the traditional test as well, then how should you go about that? What is the perfect ratio in your project? Of course, I don't know what the perfect ratio is, but I can leave you with two strategies to go about when you want to try out property-based testing in your project. The first one is to start traditionally. So when you write a new piece of code, you start maybe using test-driven development or not, but you start with the simplest implementation and don't worry about properties. You write the simplest implementation, you write the code, then you think about the test, then you think about the edge cases, then you improve your code and so on. And when you think you have it right and you have all the edge cases you could think of, only then start thinking about properties. And then maybe the property-based testing will find some bugs for you, so you fix that. You come up with new properties. You go back talking to your product owner about the correct data. You talk to your colleagues, and so on. And in this process, you may find more bugs, more holes, more misconceptions. So that's kind of a long story, but it's a fun one. You gradually arrive there to some kind of certainty that you did everything you could. And the second strategy is to only provide properties for the key parts of your system. You don't have to have them everywhere. Maybe, what does it mean, key components? It may mean, for example, the most complicated bits. I don't know, some accounting, financial stuff in my experience, where you're not really sure if you understand it, it's written somewhere by someone, and then when you approach it, you provide property-based tests, you start to understand the code more, you start to gain more certainty that it's correct, because you provide the properties, you provide the test, and the testing library may find out something interesting for you. Or the key components can mean just the core parts of your system, the ones that make money maybe, or make the customers happy. So that you want to make sure that you did everything you could to make it really perfect or as close to perfection as you can. So use your energy and your time to provide property-based tests for those pieces. To sum up, the property-based testing is something which doesn't come at no cost. They will take you more time, they will take more of your energy, so they have higher cost, but also they give back the value that no other kinds of tests can give you. So that's pretty worth it in my opinion. Where it shines is in finding edge cases and misconceptions with the way you are thinking about your code. The most tricky part, but also the most fun part, is coming up with properties. But you'll get better once you try it. You'll get better with it with experience. And the most important thing, I think, is to find the right balance. Because I cannot advise right now, I don't know, 50% properties, 30% examples, or some other ratio. But if you look at your project and find the right balance and the right places where, in your opinion, it's worth to add property-based tests, then you know you did everything you could to make your code correct for the data and known edge cases, as well as you are prepared to discover the edge cases that you haven't even dreamt of. If you'd like to know more, there's a couple of great resources. The jQuick documentation itself has a lot of other features that I couldn't cover here, and also it suggests some ways of coming up with properties as well. The second link it's actually a book, but you can view it an older version online. It's in Erlang, but it doesn't matter because the concepts are the same. So it's a highly recommended read for coming up with properties, for understanding how to think differently about your code to come up with them. The third one is the list of patterns, and the fourth one are examples from this presentation written up in a repository. Thank you for your time. If you have any feedback or comments, I will happily take it under this QR link or through the Devox app. And if there are any questions, I think we have a couple of minutes now. Thank you. There's a question.
Thank you very much, Magda, for the presentation. It seems very useful, and I appreciated that you already covered a lot of questions about balance between unit tests and property-based testing. My question is, are these property-based testing time-consuming? Because I imagine that you've got a lot of random properties, so is it possible to use them in real time, during the development? And also, I have quite some concerns about non-determinism. So, is it possible to have a seed of the test suite that actually failed to be able to reproduce it easily? That are my two questions.
Okay, so let's start from the second question. If there's non-determinism, then can you have some kind of a seed for it, right? So yes, and actually, if there's random data, there's always a seed, and jQuick is so nice to print out the seed for you when the tests run. So for example, if there's somewhere in Jenkins, the library has discovered the bug for you, you can take that seed, you can make it a regression test that runs for that seed every time, so that you are safe for the future, that this kind of data will always make a green test in the future. So that's a good thing. And the first question was about is it time consuming and can you use it in your, I guess, basic unit suite and so on. So in my experience, yes, I always just make it part of my test unit suite. And apart from example-based tests, I have property-based tests for the simplest and fast unit tests. But if you have some kind of integration tests or tests that write to and from files, so on, sure, do have that in your suite as well. But maybe you don't want to run it 1,000 times. Maybe you want to specify for the test that only run it 10 times or only 100 times because it's time consuming so that it doesn't slow you down. So that's definitely possible.
Thanks, Magda. That was really insightful. I had a question about your testing strategies. You said to write properties-based tests for key components. So can you just explain a bit more about what that component size might be? Are we looking at like a class level or like a module level? And what's your experience been in writing properties? Like, where do you find the balance? At which level should we write the property tests?
So the question is, what is the size of the component that you might want to test with property-based testing?
That's right, yeah.
Right. So I guess it depends. You can treat it as any kind of the tests. So it's fine for you to use it in integration testing, for example, when you have a bigger piece of code and you want to make sure it behaves correctly. But with this consideration that maybe don't run it 1,000 times. So if, for example, you have your system and you are testing that if you are giving it random data from the mocked user, which is your then property-based library, then it runs to the saves something to the database and back, and that's your safe boundaries. So I would recommend to have at least a couple of such tests, bigger tests as well. But also, for me, it's sometimes it's easy to also add very easy and small unit-based properties, just to see if they will find something useful too.
Thank you. I think we have 2 minutes left. Any more questions?
Thank you very much. If anything comes up, I'll be around.